Good afternoon, everyone. I'm happy to be here today and to present a little bit of the work that we're doing at Govs. Today I run a data governance and management company called Govs, and a lot of the work that you see here today is only made possible by a lot of our engineers who have worked hard to make sure that we have a fully functional and scalable product. So I want to thank them. Some of them out in the crowd and didn't want to come up today, but I want to just thank them for some of their work before I begin.
Yes.
Huh?
We're not seeing what you see.
Oh, God.
Bear with us, everybody. Thank you very much. So, this is well worth you listening up for because this is fabulous.
Great.
Oh, we have that. Why are you listening to me? Listen to him. All right.
Great. So let's get into it. So today I'm here to talk about Govs API, which is an API that connects to the physical world, specifically internet-connected sensors and machines, basically connected to the internet. This is a simple, secure, and reliable API for all your people, processes, and things. It works in 3 steps: connect, automate, and monitor. So for any developer in the room, connect is simply allowing any organization that we work with to connect to their cloud data warehouse, whether it be GCP BigQuery, whether it be AWS, or whether it be Microsoft Azure. We connect and leverage that as storage, and what we provide to them is a single place to compute and process data for Internet of Things devices. So how do we get to this point? So just as he was kind of mentioning before, as somebody that's ran a developer group and had a wonderful chance to kind of work at some big companies as well as small companies, one of the biggest things we saw was how huge the Internet of Things was, especially as you think about the connected cloud. You see today in cities like Miami, there are hundreds of thousands of devices that are connected to the internet that are sending data, but guess what? Every time an elevator or an HVAC machine or a flood sensor goes down, there is no JIRA for developers or engineers to say, this is an issue, this is something we should respond to. And one of the things we saw as we kind of did this development was seeing some of these problems with big companies that had fleets of devices connected to the internet that didn't have a single uniform kind of like pathway to understanding what the data was or what things are going on. And this gets to some things, right? So if you look at the history of kind of like compute, it's kind of like the 1960s to the 1970s, which were around mainframes and centralized data. And then we kind of get to the 1980s to the 2000s, which is about client-server, which is distributed. And then we kind of got to the 2005s to the 2020s, which was really focused on this idea of mobile and cloud. Cloud computing took over. People began to start putting more things in the cloud. And today, we live in a world where the cloud is getting tons of data, petabytes, terabytes of data. And what's becoming interesting is what we're seeing in some of the work that we're doing is the same teams that had developers and strong software development engineering kind of practices are now facing new needs. And this is centered around code. I mean, not code, this is centered around data. And this is centered around the problem of data of how do we organize and manage this massive amounts of data that's now going up in cost. We see a shift, and that's coming back to edge intelligence, which is distributed today. And you've probably seen it. If you're here in Miami Beach, you've probably seen an autonomous vehicle that's driving around. You've probably looked out and seen kind of a solar-powered kind of like machine around. There's a lot of things today that now have the same or similar compute and like processing power as our cell phone. And now the thing becomes, what happens when all of these things have or need to connect to the internet? What is the API that connects them? So here at Govs, what we've seen is data is queen. Data is becoming the thing that organizations need to manage and process, and this all goes back down to how good is your data? Is it reliable? Is it secure? How do we improve upon your data? How do we get better data analytics? How do we get better data and AI? So A16, one of the general partners at a venture capital firm, came up with this thesis called the end of cloud computing. And in it, he said, hey, sensors and data explosion will kill the cloud as we know it. Why? There'll be a ton of sensors. They'll produce a ton of data that's going to cause a lot of geospatial needs. Existing infrastructures today won't be able to handle the volumes of data, and this will shift things more to a distributed. So if I'm saying this today, I know a lot of you guys are looking at me and saying, he's gone crazy. But what we see is a need for edge computing, especially as you think about all the different machines that now have AI systems, such as things that connect to cameras, video, that now use facial recognition systems, image classification, and are making decisions that impact the real world. So what we've seen in the developers and data teams we've reached out to is, 1, there's no time. 2, there's too many integrations. And to kind of give an illustration of this, just think about all the internet-connected things that are in your house. You may drive a Tesla, which is an electric vehicle. You may have a smart TV. Think of your connected home. There's your HVAC system. There are all of these different things that combine to make a really robust and kind of smart infrastructure. Now businesses, organizations, and even cities themselves have this challenge of organizing all this data to do simple things like track how safety is, track sustainability, and track efficiency. I know I'm at a developer talk, and I'm going to get to why this API is really important, but I just want to illustrate the problem we saw and why we built this API. So we realized we have one thing: speed of execution. With an API, instead of working with teams to kind of connect them to another UI or connect them to something else that adds to their workflow, by creating a single standardized API that communicates with all these different machines and devices and things, they could build really incredible applications that can interface and support real-world business problems, such as helping the city of Miami track all of their scooters and manage the scooters better, for example. So we believed in this theory of create value ASAP. And what we found in creating value ASAP, kind of like this picture here, is we went out in the field and manually looked at all the problems happening with the devices and issues and machines. What we realized is that there needed to be a better way to track issues around data. Data quality is becoming really important. And while engineers and software practitioners are great at kind of solving the nitty-gritties of software development and code, there needed to be a kind of better way to manage this around data and make it easier for developers to participate and help solve problems. This came back to the data teams and the data practitioners like data scientists and data engineers who are worked with. So Govs has created an API that lets you integrate once, integrate fast to all of these different applications and devices and things. We've done this in a few ways. One, we've looked at data governance in the traditional cloud data warehouse model, and we recognize that, yes, if there's terabytes and petabytes of data, it's going to get really expensive if you're just storing this in the cloud. But guess what? If you have better processing compute engines that lowers that cost as well as give you real-time information, it helps in organizing that data, no matter what cloud you're on. We've tested this out, and we've actually gotten a lot of organizations that are adopting this that have physical operations, from nonprofits to the big organizations like Microsoft to even the city of Miami, that are using Govs and the Govs API to power their entire smart city infrastructure. We think we know there's a problem, but we also know that there needs to be better tools to access this problem. By creating a single API, we're able to unlock and showcase things that even the city didn't know was kind of connected to the internet, which is really impressive. So again, back to the model. How does this work? Why does this API matter? So what we've seen is there's 3 steps that make this really turnkey for developers. 1, a place to connect to different data sources. 2, a process to automate this. And when we talk about automation, we're not talking about a Twilio API that sends an SMS notification or email. We're talking about real automation. We're talking about being able to feed thousands to hundreds of thousands of images and classify this to determine, is this an issue or is this not? And then being able to monitor that in the tools that people trust and use, whether that be a monitoring solution like New Relic or something like Datadog. We've seen this and have illustrated this API on something called Helium. If you're unfamiliar with Helium, Helium is a 700,000 hotspot network that was designed by the people. It's a blockchain. We've been able to create an API that adds on and supplements a lot of the things we found missing within Helium to determine each location of each hotspot, as well as their geographic location, which building they may be in, and supporting more organizations and teams to tap into this network. People that own these hotspots today can get Helium credits and tokens in forms of crypto, but these hotspots connect to sensors such as internet-connected devices, and what it can do is do data transfers to make sure that the data communicated from those sensors are happening in a better and effective way. What we see is organizations are tapping into this to look at environmental monitoring and looking at leveraging our API to help make sure that the data is secure, reliable, and ties into their existing data infrastructure and data stacks. We've seen this growth here in Miami by the increase of these hotspots coming up to 2,684 with about 654 hotspots offline. We've also seen this in just supplying better data through dashboards and mobile apps that have helped the different users that are leveraging our system and their different workflows. What this comes down to kind of showcase this a little better, is simple UIs that make it really easy to create a standard around data. So in this UI piece that I'm just showing to you, which leverages Govs API, I'm able to kind of show you different things such as symbols around sensors. So on top here, you have infrared motion sensor, you have a security camera, you may have a temperature sensor. But what we found is by making it really easy to break down the use case of the sensors, you can find the accountable organization that is behind the sensors, the purpose of the sensors, the technology behind it, and even get down to how it's done doing data process who's accessing it, and who has storage. We can even get this down so people can leverage this for API management, such as using our access token and then getting access to this service to help them as they scale up across thousands or even hundreds of thousands of devices. So let me take it back to what people can do with this and what we've seen people do. Today, cities like the city of Miami are using DataGov's API. Oh, it disappeared. All right, let me go back to it. Okay, great. So they're using this API to do things like issue tracking for all their different IoT and machines. Simply, they can use our mobile app interface or their own interfaces to track data for, such as 311 requests. Don't know why it's going in and out, but to get to the point, they're able to track issues in real time using this application. We're also seeing them able to leverage tools like LiDAR in their workflows. So using DataGovs, they're able to tap into the LiDAR sensors on their iPhones and able to leverage the camera's computer vision to basically track compliance and monitor such things like when scooters or bikes are parked in specific places. They can even do this at the street level, creating 3D renderings that they can then leverage for better planning and better preparation, all on a single API that they can then reference later. We've even seen organizations use this to mock and plan for deployment of air quality sensors or flooding sensors, such as this air quality sensor that's here today. And what they're using these renderings to do is to plan and better predict places that they can help in better assessments to reduce things like greenhouse gas emissions here in Miami. These are even being used in things like buildings to track. And lastly, we're even seeing this going back to the monitoring of tools. With a single API, organizations can then import the data in their tool of choice. We've seen analysts use this for things like Tableau. We've seen them use this for things like Power BI. And all of this just supports them with better data and reliable data that they know they can trust and have a reference to. If you're interested, the Govs API is active today. We're powering organizations like Citicoins, Helium, even organizations in Europe like IOTA, and many more, and leveraging this to make sense of the physical world, leveraging digital. Thank you.